All right, let's solve a couple of equations just by taking square roots. This is the ideal situation, I guess. If you have a quadratic, if you don't have a linear term, then you can just do what we were doing with completing the square, except you don't have to complete the square. You just take the square root of both sides. The reason this one has a little bit of difficulty to it is because it's negative and it's not a perfect square. So because we're taking the square root of a negative number, your calculator tell you, hey, there's no real answer to that. So we're going to put an I out there to represent that we are now in the imaginary world, but we don't need the negative sign under the square root anymore. Because what we're doing is we're splitting that into the square root of -1 times 40. By definition, the square root of -1 is I. And then the square root of 40 we're going to have to deal with separately. What's the square root of 40? That's the square root of 4 times 10. The square root of 4 is 2. And so this is equal to plus or minus 2I square root of 10. We can do a similar thing with this. Subtract 6 on both sides. 7k squared is equal to 133. Divide by 7 on both sides. You get k squared is equal to 19. Square root of both sides. K is equal to plus or minus the square root of 19. And we're not going to fiddle with that anymore because 19 is a prime number. And so it's going to create an irrational number when we square root it. So we're just going to leave it like that. Okay. Real quick, let's do a quadratic formula question. I'll do number 17. Quadratic formula is above. Notice how it says this or this. The plus or minus in the square root or in the quadratic formula is what gives you two answers. One of the answers is done by adding the two things in the numerator. The other one is done by subtracting the two things in the numerator. Okay, but before we can do that, we have to get everything to one side. So we're going to have to add 6 to both sides. Creates 11x squared minus x minus 8 is equal to 0. Okay, I'll point out that you could try to factor this. You could try to complete the square. Both are fine options, but maybe not the best for this particular problem since the middle number is odd. So it's a -1, and the leading coefficient is 11. So it's not 1. So let's do it. Negative b. Well, first of all, we got to know 11 is a, b is -1, and c is -8. So -1 is just 1, plus or minus the square root of -1 squared. It's just going to be 1 minus 4 times a times c. You're right to say that I didn't put b as -1, not just 1. But if you do -1 squared, it's the same as 1 squared. It's just 1. Over 2a, so 2 times 11. So we get 1 plus or minus the square root of 1. Oof. Whose idea was this? 32 times 11. 32 times 11 plus 1. 353. Over 22. So what's the square root of 353? Nothing friendly that I can think of. Maybe. We'll see. So if we check out the square root of 353, we see that it is not a perfect square. But does it have a perfect square up in it? It doesn't have a 4. Try to divide it by 4. Ain't happening. Can we divide it by 9? No. Probably can't divide it by 16 either, can you? Can you divide it by, not 25, can you divide it by 36? No. Can you divide it by 49? No. Can you divide it by 64? No. Can we divide it by 81? This is so gross. All right, so I guess we're just gonna have to leave it alone. This is my answer. X is equal to this. Yippee. right? And we'll call it quits there.